The last stage of memory that we're going to talk about is long-term memory. So far we've discussed sensory memory and working memory. If information is encoded properly through proper rehearsal and meaning and assigning meaning to it, it's stored in long-term memory so that it can be retrieved later on and brought into working memory. So long-term memory stores information organized according to meaning. I like to think of our long-term memory as like a filing cabinet because that's very much how it works. I'm going to have you, when you're finished this video, listen to this short clip from NPR about why we tend to scramble up names. So if you've ever had someone run through like a whole litany of names before finally landing on yours, like I'll sometimes even call the girls the dog's name by accident, you'll understand more of this filing cabinet analogy. So long-term memory has two main subdivisions, and those are declarative memory and procedural memory. Your procedural memory is just like it sounds. It's your memory for procedures or actions, or think of it like muscle memory. So like brushing your teeth, riding a bike, any of these types of procedures that you may have to effortfully think about initially, but after a while just become commonplace. You don't have to think about it. Those are examples of procedural memories. Driving is an example of something that right now, if you're just learning how to do it, you probably have to think a lot about it, but it's going to become mindless after a while. Declarative memory, on the other hand, is further subdivided into two: semantic memory and episodic memory. Semantic memory is what we're doing right now. We're storing information for facts and knowledge in our declarative memory. Whereas episodic memory is memory for personal things that have happened to us. Here's my mnemonic or my way of thinking about episodic memory is it's our memory for episodes in our lives. If we think of our whole life like a TV show and everything that happens to us like an episode, I think of episodic memory that way. So semantic memory, memory for all of the types of things that we learn about in school, including language, a first language or a second language that we've learned. Episodic memory being our memory for personal experiences and events. Again, just to review, procedural memory, our memory for motor skills, like the ones I've already described, but also we learned in previous chapters about classical and operant conditioning. Those types of conditioned responses are also a product of our procedural memory. The biological basis of long-term memory, if you remember, the storage of memory is enabled by this structure right here called the hippocampus. You'll never forget seeing a hippo on campus. So it's the responsibility of the hippocampus to move information into long-term memory. But something that we're going to learn is that memories are not stored in any one place in particular in the brain. Memories are stored throughout the cerebral cortex. The engram, or the physical trace of memory in the brain, what research has shown, including Carl Lashley's research, is that, again, memories are not stored in any one place in the brain. What Lashley did was actually take apart rat brains. So he would teach them how to run a maze and then remove different parts of the brain to see, like, which part of the brain could he remove, and then the rat would forget the task, the maze learning that it had learned previously. And what he found was that no matter what part of the brain he removed, it was not erasing the rat's memory of what it had learned. So we know that memories are stored throughout the neurocircuitry of the brain or at the synaptic level, so that space between neurons. But there's no one place in particular where long-term memories are stored. This gentleman named H.M. is the case study in something we call anterograde amnesia, which is an individual that has an inability to make new memories, particularly new declarative memories. So H.M., when he was a young man in his 20s, was experiencing really severe seizures. Surgeons removed his hippocampus, and what they found, and this, they don't do surgeries like this anymore. There's no more hippocampal removal surgeries that are done for epilepsy, but at the time they removed his hippocampus and it erased his ability to form new declarative memories, meaning H.M. woke up every morning, looked in the mirror, and was surprised by what he saw. Every person who interacted with him would have to reintroduce themselves to him every time they met him because he didn't remember them. we're going to watch a video of a gentleman who is very similar to HM, only lives in his working memory all the time, doesn't have the ability to form new declarative memories. So the process by which short-term memories are changed to long-term memories, or the process by which information is passed from short-term to long-term memory, is called consolidation. That is the process from hippocampus to the cerebral cortex, how memories are stored in long-term information. We know, though, not just the hippocampus plays a very important role in memory formation, but the amygdala also plays a really important part. The amygdala strengthens memories that have very strong emotional associations. And if you, I think we've talked a little bit about 9/11 and flashbulb memories, but just in case we haven't by this point in the year, many of us that lived through 9/11 have what we call a flashbulb memory, a very vivid, episodic memory of everything that happened that day, like exactly what we were doing, where we were. Your grandparents might have memories like this of when John F. Kennedy was assassinated. You remember exactly where you are when you heard the news. The amygdala is involved in the formation of these flashbulb memories. After 9/11, researchers did a study of people who were close to ground zero versus people who are a little bit further away from ground zero, but still in New York City. And what they found is when they asked individuals to retrieve their information, or rather retrieve their memories from that day, while in an fMRI or functional MRI machine, people who were a little bit further from ground zero had activation of their hippocampus while retrieving the memories, but people who were very close or at ground zero had activation in their amygdala as well. So we know the amygdala plays an important role in storing emotional memories and also these types of flashbulb or very vivid episodic memories. Long-term potentiation is the process by which memories are strengthened over time. Remember back from the learning unit. The more time we retrieve a piece of information, the stronger the connections become at the synapses of the neurons that store that memory. But remember, those synapses are throughout the cerebral cortex. Retrograde amnesia could be caused by something like a blow to the head, some kind of head trauma, is an inability to remember information that you learned before that accident. As opposed to anterograde, which is the inability to make new memories, retrograde amnesia is the process by which, again, through some kind of trauma to the brain, whether that be a blow to the head or the use of psychoactive drugs like illicit drugs, there can be a loss of previously stored memories. All right, so think of it as like the opposite of long-term potentiation, whereas long-term potentiation strengthens memories over time. Retrograde amnesia results in the loss of previously stored memories. The very last thing I'm going to talk about is something called infantile amnesia. I want you to think about this. Do you have any memories from when you were really, really little? From when you were, let's say, like before, like younger than 4 or 5? Odds are you might have a couple. Although I challenge you to go home and ask someone who knew you at the time and was part of that memory to see whether or not your memory is actually accurate. That's a whole other thing we're going to talk about. But the first 4 years of our life is largely blank. We file away our memories in a way that uses language that children don't really have the ability to do. So the process of memory consolidation involves meaning making. It involves the use of language that little kids just don't quite have, and that's why researchers think this infantile or childhood amnesia exists. The hippocampus is also one of the last brain structures to mature. So that, again, leaves very young children at a disadvantage. I actually forgot that in addition to infantile amnesia, I wanted to discuss the reminiscence bump as well. This is some really interesting stuff. The age that you're at right now is a really interesting age for memory retrieval. You'll find that while we talked about childhood amnesia, there's what researchers see as a reminiscence bump, teens, early 20s, where you actually have a lot of memories from this particular period of your life, particularly memories that are related to yourself or things that have happened to you. And I find this really interesting because I have a lot of memories from high school. And researchers, well, there are several different explanations, but one of the explanations is that you have a lot happening to you at that point in your life. Another is that a lot of times you have very emotionally charged things that are happening at this point in your life as well. So again, there's even more explanations, but I just think it's really interesting that when people are asked when they're older to retrieve memories, a lot of them come from this period of time that you're entering right now.